So for this video, we're going to look at the derivative of two trigonometric functions, the sine and cosine. Now, normally I would show you the proof, but we don't have time for that. But we're going to use we would have used these two special trig limits that we talked about before. And if you ever want to see that process completed, let me know. I can show you. So I'll just give you the results. And show you this. This is not a proof. It's a good demonstration, though. The red graph is the graph of sine, as you can see. And I can move this point around, and you can see the dashed line would be the tangent line. And that little orange line going up and down is indicating the slope of that tangent line or the derivative of this function, which is sine. So you can see, like right here, the slope of this tangent line looks to be about up 1 over 1. So you can see this little dot is at 1. As the slope gets less steep, say here, it's still positive, but it's definitely less than 1. So you can see this yellow dot indicates it's about 0.1 until you get to the peak of the sine, which I can't really get to. It won't let me stop. But the peak, it looks like the slope is going to be 0. So that's why the orange slope is at 0. And then once you get past the peak, the slope becomes negative. So that, so that little dot goes below the x-axis. And then the steepest it gets is about here. And that slope is a -1. And as you go to the right, it becomes less steep, but still negative. So you can see this yellow dot is indicating the slope is getting less negative until it gets to the value here, which would be 0. That's why that yellow dot is going right through 0. So the yellow dot is just giving the value of the slope. Now, remember what the slope is. The slope is the derivative. So the derivative of the sine is given by the location of that yellow or orange dot, whatever you want to call it. Now, if you want to trace that orange dot, which I'm going to do, what happens? Now, this is just the sine graph shifted over to the left, pi over 2. In other words, it's the cosine graph. This shows you that the derivative of the sine is actually the cosine. So even though that's not a proof per se, it's a good explanation or a good example of why the derivative of sine is cosine. Now, if we flip-flopped and made the graph cosine, you would see that the slope or derivative of cosine looks like the sine graph, but it's flipped. In other words, it's the opposite of sine. So the derivative of cosine is negative sine. So those are the only two derivatives you're going to know in this of trig functions in this chapter. We'll get to the other trig functions later. Some we'll get to a lot later. But this is how it works. If I now ask you to find a derivative of the trig function, the trig function has to look like this, exactly like that, sine x or cosine x. Or it could follow one of our basic rules. You could have a constant multiplied by it. It would still work. You could have another function added to it. It would still work. So for example, if you had y equals 3x to the 4th minus 2 cosine of x. You could do that. And the reason you can do that, and this is important, it's because we have rules and theorems that tell you you can. You can differentiate across a difference. And we know the derivative of cosine from up here, and that 2 multiplied by cosine doesn't matter because we have a rule that says if you have a constant multiple, you can ignore it. So this derivative would equal 12x cubed minus 2 times the negative sine x, or 12x cubed plus 2 sine x. So that's an example of one you can do. Let's look at an example of one that you can't do, so you really understand what I mean about following rules. Because that's the most important thing in derivatives, making sure you follow the rule. Say we had y equals the square root of 2x minus sine 4x. This you cannot do yet. We will learn to do this later, but you cannot do this yet because it doesn't follow any rules. This rule specifically, this theorem specifically, shows us how to take the derivative of sine of x, not the sine of 4x. So that eliminates this from our problem list that we're able to do at this point. If I ask you to take the derivative of this, you can't do it. We can easily take the derivative of x. We can easily take the derivative of sine of x, but we don't have any rules or theorems that allow us to take the derivative of a product, x times sine of x. We only have a rule that allows us to take the derivative of a sum or difference, which is why we could do this, but now cannot do this yet. So one last example. Can we take the derivative of this function? Well, if you start to look at it and rewrite it, this is fine. This we can use our constant multiple rule. This also, pi is a constant, so it's pi times sine of x. So we can ignore the pi, which our constant multiple rule says we can, and just take the derivative of sine of x, which we now know we can. So this one you can take the derivative of. The derivative is negative 6x to the negative 3 minus pi times the derivative of sine, which is cosine of x. We're going to simplify this a little bit. Negative 6 over x cubed minus pi cosine of x. So hopefully you can see that just adding these two trig derivatives doesn't make our lives much more difficult, because derivative of these functions is easy. Sine becomes cosine, cosine becomes negative sine. What you have to watch out for mostly is when are you allowed to and not allowed to take derivatives. know what rules we have, and know what rules we don't have, and make sure you're following the rules. So that takes care of the trig for now. The next video will be focusing on other functions maybe that may not look so easy to differentiate, but when we think about them and apply algebra, they are not that bad.